All right, 6th graders, we're going to be talking about lesson 13.4 today. Lesson 13.4 is about graphing linear equations, it's called. Graphing linear equations. Okay? Now, what those words mean is we're going to graph, meaning draw a line, on a coordinate plane. A linear equation tells us it's going to be a straight line. And an equation means that we're going to start with an equation and then we're going to make a chart of x and y values so that we can draw the line. Okay? So, let's first look at the example. At the top of your worksheet there's an example. What is the equation given in the first example? Maddie.
What?
Come on, listen please. What is the equation right at the top? It says graph the equation on the coordinate plane, at the top of the sheet. What equation is given?
2x plus 1.
Right, y equals 2x plus 1. Now, they made a chart. I said this is usually how the chart is going to be shown. It's easier to see the tables, or the values listed as a coordinate, or an ordered pair. Then, choose 3 values for x. Write each value for x in the equation, find the corresponding value for y. That's the same procedure that I gave you. Choose numbers to use for x. And what numbers did they choose for x, AJ?
They chose -1, 0, 1.
Good. -1, 0, and 1. Why would they choose those numbers?
Because they're fun.
Because they're fun.
And they're all in a row.
They're all in a row. Those are all good reasons.
Because they're easy.
They're easy to work with. It's easy to multiply a number by 1, right? It's easy to multiply by 0. It's easy to multiply by -1. So these are 3 good numbers to use. Oftentimes these are 3 good numbers to use. Now, what do we do with these numbers? Step 2. What does that say? What are we going to do, Garrett?
Right ordered pairs, plot the points on the coordinate plane.
Nope, it says right here. We've chosen the numbers,
Put
and now we're
them
going to
into
put them into the,
equation.
right, into this equation. We're going to put these numbers into the equation. And here's how you do that. Again, on your sheet, it shows you this example. We're going to use y equals 2, but then for x, we're going to put in this number. We're going to put in one of the numbers that we chose. Instead of writing x, we're going to write -1. And then use this again, plus 1. So the only thing that we're changing there is what, Sam? Pay attention, please. Yep. We're writing the number in place of the x value. Now, what are we going to find, Laura? The answer. What is that answer going to give us? Okay, we're going to pay attention here. All right, stop looking around. Sam? What y equals? Right. We have to solve this. 2 times -1 plus 1. What does y equal when x is -1? What does y equal? What is the answer? Gracie.
-1.
-1, yep. This is -2, because 2 times -1 is -2, plus 1 equals -1. That's what it shows on your sheet. 2 times -1 plus 1 equals -2 plus 1, or -1. So these two numbers go together. those two numbers form an what? An ordered
Pair.
An ordered pair. So next to -1, we write -1. Next to 0, we're going to repeat the process for 0. Y, whoops, still in the, there we go. Y equals 2 times 0 plus 1. When x is 0, y is
0.
no.
Y is
1.
1, because 0 plus 1 equals 1. So these two numbers go together. 0 and 1. Now, put the last value in for x. Y equals 2 times 1 plus 1. 3. Yep. 2 times 1 is 2, plus 1 is 3. So, these two numbers form an ordered pair. Now, what do we have from the chart? We have 3 what?
Numbers.
pairs.
3 points, 3 ordered pairs. Right. So what could we do with these?
Mark them on the.
Mark them on the graph, and then draw the line. So, -1, -1, 0, 1, and 1, 3. Notice they form a what?
Line. Straight line.
Right.
An arrow.
Yep. Let's do number 1 together. No, that was the example.
Yeah, but
No, it's not. This is 4. We're going to do 4x plus 1 now. Number 1, and your assignment. First, make a chart, x and y. Step 1, make a chart of values. So, next to number 1, make a chart. Now, choose numbers to use for x. Let's choose the same numbers. What numbers did we choose before?
-1, 0.
1, 0, -1, or -1, 0, 1. Doesn't matter what order you choose the numbers. Yes?
Are we going to want to use the same numbers for every problem?
Probably. Those numbers are easy to work with. Okay? Now, let's substitute those numbers in for x each time. Go ahead and do that. You can do that on your own now. I'll write them up here. Sam? What does the first one equal, class?
5.
What? No?
5.
5. What does the second one equal? Not 4.
1.
4 times 0.
0.
Plus
1.
Okay. So this equals 1. And this one equals what?
3.
What's-
-3. 4.
4 times -1 is -4.
Plus 1 is
Plus 1 is -3.
See, I told you.
Okay?
Yeah, they make
Quiet, please.
And then you mark it up.
Now mark those on the graph.
Wait, why do we have to choose those numbers? The 1.
We talked about that, Asa. We choose those numbers because they're simple to work with. You don't have to choose those numbers. You can choose any number, but try to pick numbers that are simple to work with.
Wait, 2.
But this one doesn't go to straight line.
Okay?
Yeah,
It does.
Yeah, it does. Yeah, it does.
Mine does.
1, 5, 0, 1,
No. Oh, yeah.
Oh, never mind.
negative 1,
Yeah, never mind.
negative 3.
It made us 3, 1.
What if you
It goes back. And then
This isn't negative 1, negative 3. See, these two numbers go together. Negative 1, negative 3. Over negative 1, down 3. Okay? Okay? Any questions? Any questions, class? Again, for the first step, make a chart. Draw the chart. Okay? Then choose numbers for x. Let's go to the back side. On the back side, they give you some real world problems that have this, use this procedure. It says Enrique is exchanging euros for British pounds. On the day he is exchanging euros, the exchange rate is 1 euro equals 0.67 British pounds. So an equation relating British pounds, y, so that's the y value, to euros, x, is y equals x times 0.67, right? So, what are we asked to do?
Graph the function.
Graph the function, but we're going to find,
Oh, find how many British pounds you need.
yeah,
Find how many British pounds you get out of the euro.
yeah, exactly. That's what we really do with this. We'd graph the function, but we could also, we're going to use this to find how many British pounds you would get, okay? No, we don't, but we can use the equation to find it. Now, replace x with 1, 2, and 3. And what are the values for y? Well, we know what 1 would be, right?
0.67.
1 times 0.67 would be 0.67. Yep. 2 times 0.67.
That would be $1, right? Wouldn't it be $1?
What's
All the same.
what?
Oh,
$1.34?
no.
Is that what you said?
Yes.
So.
Or 134? 1.34?
Yeah, that's what it is.
So 1.34 and 3
What's the symbol for
times 0.67.
20,
It
20,
should be 2.03.
Well, if you just add
It's 19 something.
134, right?
It's 19 something.
2.3.
So 2.3.
2.1. 2.1.
This is 1,
2.01. 2.01.
Oh, I was right in my head.
0.
Yeah.
Yep. Now, they give you a space to make a graph. But what you should probably do is use a coordinate grid like this. Okay? If you made this, if you just use this blank space, it's not going to be very accurate. So, use either graph paper or use one of the blank graphs that you have. And then, for each dollar, I'm sorry, for each euro, you're going to get British pounds, right? So the British pounds are the Y number and the euros are the X number. Alright? Now, our euros are in whole numbers, so if we just put these as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Each of those is just a whole number that we're working with. The British pounds is not a whole number. So, what would be an appropriate scale?
Negative? Oh, no. No, no.
No?
50, 0.50. 0.5.
0.5? Yeah, that might be a good one. Look at the numbers.
Or 0.50.
0.5. So then this is 1, 1.5, 2, 2.5, 3, 3.5, 4. That's a pretty good scale. Good job, Noah. Then, we need to mark these points. Okay? So where would 1.67 be?
Like, almost half, 1 and 2.
Yeah, right above the half point, right? And 2, 134. Right below the, what? The 1.5. So here's 1.5. And where would 3, 2.1 be? 2.01. Right, almost at exactly the 2. A little bit higher than the 2. Right? Now, when we draw this line, we get a line like this. You see that? And that gives us, it helps us to predict where the, what you would get, or by looking at it, you can see sometimes people that work in the markets, or the exchange markets, they look at lines like this, and then the lines actually change over time. So the exchange rate might fluctuate daily, and then the line would actually curve. Okay? You're doing the same thing for 6 and 7. Okay? In 6, instead of this equation, they give you a different equation. In number 6, they give you this equation, y equals 3x plus 8. Okay? And then, you're going to make a chart. What is the x in number 6? What is the x line in number 6? X tells you the number of tens. And y is the what? Caleb? The cost. Yep. So, this is when you choose the x values, or actually they give you 3 and 8 to use. 3 British pounds and 8 British pounds. And so this is the pounds. And they want you to find the number of tens. Let's do this one together.
Yeah.
Because they, for 3 pounds. Yeah, they kind of threw a curveball at you a little bit here. All right? So, look at it this way. When we put in the cost of 3 pounds, how many tens does that equal? We'd have to find what equals 3. Wouldn't we? What number here would give us 3? Negative something, yeah. Well, if we got negative 5 here, 3 times something equals negative 5. And then plus 8, we would get 3 pounds. Huh. I think they meant to have these the other way. Let's just change this, okay? On this one, let's say that they use 3 tens. Find the total cost for 3 tens and 8 tens, okay? Class, we're just gonna, I want you to write this down next to number 6. Cross off pounds, 3 British pounds, and write tens in the equation, or in the problem. And next to 8, cross off 8 British pounds and write 8 tens. Okay? Yeah, it doesn't matter. Then, make a chart and write 3 and 8 next to tens. So 3 and 8 are the tin numbers. Those are the number of tins that you're buying. Okay? Quiet, please. Now, substitute the 3 in here. If this were true, how many would 3 tins cost? How many would 3 tins cost? Amelia? Look, 3 times 3 is 9, plus 8 is 17. Yep. So 3 and 17. Okay? How many would 8 tins cost?
32. I know, you have to make it fit.
3 times 8 plus 8.
32.
32.
You have to make it fit.
Okay? Now, yep, to graph those, you may have to go and extend the chart.
I know, yeah.
Alright? Or, like I said before, use your own graph paper. And then make a graph. So then we can graph tens and pounds. Okay. And for 3, 1, 2, 3, 8. Then maybe we go up by 2. So on mine, go or let's see, I need 32, so this probably should be 40. Right? 4, 8, 12, 16, 20,
It does cost.
24. So then 317 and 832. Okay? You see how that works? Yeah, good. Yep, you extended the graph. Yep. So that's how you graph an equation like this, a real world situation then. Okay? No, you can skip this.
What?
Go back to the other side and finish graphing those equations.